Immunizations are extremely powerful tools, and actually it seems that in the history of medicine and of public health, the effect and the impact of immunization campaigns and immunization in general is comparable only to clean water. This is very important to understand how the balance between deaths associated to vaccine-preventable diseases and the dynamics of populations have changed over time. We're not dealing anymore with deaths about smallpox or polio or other infectious diseases thanks to immunization. But actually, since we have in our hands so powerful tools, we have a number of potential targets and objectives that can be reached with immunization campaigns. One is eradication of diseases. We were successful in eradicating smallpox. This means that actually smallpox does not exist anymore. There's no circulation of the infection agent all over the world, and actually this effect was possible only thanks to supporting immunization campaigns, ensuring very high immunization coverage rates, and having a very strict and strong surveillance system for avoiding to miss potential cases left in the community. So if we were able to eradicate smallpox, we will be able to eradicate other diseases. This is very important because this effect can be obtained only for possibly for diseases transmitted from person to person, like smallpox, polio, and so on. But at the same time, the impact of this objective, of this target, is very important because it justifies the very important efforts that we make for maintaining immunization strategies. Actually, one of the things that we want is immunizing so good the entire population of the world that at a certain point we will stop immunization because the disease will not exist anymore. A second target of immunization campaigns is elimination. The very easy example here is polio. We have eliminated polio in several regions of the world, although we have still a number of cases in other countries, and there's still the potential to spread cases in others. Actually, when we eliminate, for example, polio from one region, think about Europe, for example, you are allowed to actually think to the next step, which will be eradication, but at the same time it's extremely risky to actually not think about the possibility of reintroduction. And this is a simple reason why even in a region and in countries where polio is eliminated, we still keep on immunizing against the disease. If we would stop immunizing, we would not actually be protected against the risk of reintroduction from other endemic countries. A lower level a lower effect of immunization and immunization campaigns actually is control. This is achieved for many diseases where we have been able in reducing the number of infected individuals and the associated effects like deaths, complications, and severity. Think about pertussis. Think about measles. Actually, measles is one of the diseases targeted for elimination in the next few years. We have achieved good levels of control already, but we have to move forward to go to elimination and possibly to eradication as soon as possible. Actually, the two strategies that we can use to achieve these objectives, which again are eradication, elimination, and control, is achieving the highest immunization coverage in a population, which means taking advantage of the herd immunity, as we explained. Herd immunity lowers the probability of being exposed to an infectious disease, simply because the number of susceptible individuals in a population is decreased. And so the probability of circulating infectious diseases is decreased as well. The other way we can try to obtain an effect from an immunization strategy or with other actions is source drying. Actually, we are not able yet to control some diseases with vaccines. Think about malaria. Hopefully, we will have in our hands a vaccine against malaria in the next few years. But one of the only ways to approach this kind of diseases is trying to eliminate the reservoir. And that's why we're focusing so much in the control of insects, because actually this is the main reservoir for some diseases. Same thing can be said also for some infectious diseases transmitted from person to person. Think again about Ebola. Source drying was effective in stopping circulation in most of the endemic countries. Now, we already said that the most important effect we obtain when we immunize is the reduction of people with infection. We don't always think about a number of other effects that are induced by immunization. When we prevent a disease, we do not prevent only infection. We can prevent cancers. For example, think about hepatitis B or human papillomavirus. We prevent infection and we prevent cancer because these two cancers are associated with infection. We can prevent antibiotic resistance. Think about pneumococcal, for example, infections. We increase survival and we increase and improve the wealth of a society. With this impact, we also affect the economic situation of a country or of a region. And we can guarantee, we can support safe travel and for the populations, because we can protect individuals even when they move to endemic countries from some diseases. This is very important, and all these effects are barely measured in studies when we focus mainly on vaccine efficacy. Now, since the effects are so large and the impact extends much beyond the problems induced by the simple infection, WHO, the World Health Organization, supported an immunization strategy that is called EPI, which is Expanded Program on Immunization, with the objective to guarantee to every individual in the world a set of basic immunizations. This program has made enormous improvements over time and actually was responsible of the main achievements in wealth and in health and the reduction of deaths and the improvement in economy of several countries, simply because we have prevented a number of diseases. It's very important that we continue and we keep on maintaining this basic level of immunization even in developing countries, simply because this is a guarantee for the development of economy and is a main achievement in public health. For understanding which is the impact of immunization strategy, we can have a look to what happened, for example, in a country, in a continent where we have precise measures of the frequency of diseases in the pre-vaccine era and in the post-vaccine era. In this table, we can see that actually we had an enormous number of cases of disease and death that have been prevented over time. In the paper we are describing in this slide, actually, there is an estimate of deaths and number of cases prevented for, I would say, basic immunizations like polio, diphtheria, tetanus. In this table, we present something which is more relevant to vaccines that we have introduced more recently, like hepatitis A, hepatitis B, and so on. You can see that, for example, for hepatitis B, in the pre-vaccine era in the US, we estimated nearly 240 deaths, and actually in the most recent year available, each year the US have measured only 47 cases of death. So this enormous number of cases prevented, again, is something that we cannot avoid to study when we think about the impact of vaccines. And the good thing of immunization strategy is that since we are not trying to achieve limited results, the number of cases prevented is always extremely high. This translates into an economic value, so there's actually a return on investment when we implement immunization campaigns, and also in a number of indirect effects, as we have said previously. If we think about smallpox, there's something that we should keep in mind, because smallpox was possibly made the history of immunization, not only because it was one of the first vaccines that the history of vaccinology have managed, but also because the impact of smallpox has been very important even in developing countries. So canceling simply a very frequent cause of death and a cause of disability was extremely important, and is something that we should keep in mind as an example to reproduce for other diseases. Think about polio, for example. Polio should be the next step, the next disease targeted for eradication. We have made a lot of progresses in the elimination of polio, and if you compare for example, the situation in 1988 with the most recent estimates by WHO in 2014, you see that we're left with only a couple of regions in the world where the infection is still endemic. So this fight against polio will need possibly some more years, but actually the final and ultimate objective will be that we will cancel this disease all over the world, and we will not be immunizing anymore against polio, simply because this disease will not exist anymore. Measles is a little more problematic. You may be familiar with the notion that even in Europe and in the US, we have been experiencing unexpected, I would say, outbreaks of polio, even when we have populations with extremely high immunization coverage. Since measles have a very high basic reproductive rate, it's very important that we reach very high immunization coverage, and we implement additional strategies for catching up susceptible individuals. There's a list of actions that should be implemented and put in place when we have polio cases that are actually needed for erasing the disease in several countries. Now, the problem is that we still have a significant number of cases in developing countries, and it's extremely difficult to achieve a better level of control because achieving a 95% coverage in a population which is dispersed over a large area and where there are a lot of logistic problems, it is extremely difficult. However, even for measles, we made a lot of good progresses, and the level of attention is very high, and we expect to have a progress even in the forthcoming years because of a stronger attention and surveillance and immunization actions for this disease. We don't have to forget that actually for diseases like measles with very high basic reproductive rates, we should implement appropriate strategies. The example of Poland is very instructive because once Poland started to immunize every individuals, they rapidly reached a very high immunization coverage for the first dose, which is in the second year of life. And you see that in 1978, coverage was already more than 90%. Still, Poland experienced a number of actually peaks in incidence of measles. This is expected because actually we don't stop the accumulation of susceptible individuals, and we need to avoid that susceptible individuals stay around in the population. So things got better only when Poland added the second dose that was in 1990. And with the second dose reaching a very high coverage at the age of 6 years, this country was able to immunize a much higher number of individuals that were left susceptible, and the results are very clear in this slide, where the incidence decreased very much. So this is a simple example of how 2 doses are needed for actually catching up those individuals that are left susceptible even after the first round of a campaign. Another example that is very instructive is what happens with pertussis. You know that immunization with current vaccines is a little bit problematic with pertussis, and in this slide we describe the situation of Italy, for example. Pertussis is also very easy to transmit. The basic reproductive rate of pertussis is close to 20, and the introduction of all-cell vaccine in the 60s actually had an impact in the circulation of the disease, but the impact was not actually very important because we still observed peaks of disease in cycles, and the incidence remained, however, high, which is an effect that is expected when you are not able to prevent the susceptibility of all individuals in a population. Things got much better when acellular pertussis vaccines were introduced, and actually a better coverage was achieved in the Italian population, while incidence was decreasing. Remember that pertussis vaccines are currently under scrutiny because acellular pertussis vaccines may prevent the disease, but according to animal models may not prevent completely infections. This means that we are not able to stop completely the circulation of the pathogen, and we are left to the chance of experience the disease again and again. So it's not straightforward to obtain good results like eradication and elimination if we don't take into account all these problems that sometimes are specific for some diseases. One other effect of immunization strategies is that if we target specific age groups with immunization strategies, we will leave room to the expansion of other age groups. In other terms, this is the example of pertussis in Italy again. If we target children in the first years of life, we will see that in proportion, the number of cases in this age group will decrease, simply because we will be actually immunizing them and we will preventing the disease in this specific target population. At the same time, in absence of other interventions, and you know that it's very difficult to implement immunization strategies for preventing pertussis in adolescents and adults, you will be having a progressive increase in proportion of the age groups that are not targeted by immunization. And actually, this effect must be again be studied to think about additional actions in immunization strategies to prevent the circulation of the pathogen and the spread of the disease by other age groups. Pertussis is very important to, as an example of the study of impact of immunization, because actually the probability that the disease circulates in older age groups, older than those targeted by immunization, is well recognized. And actually, we don't have in our hands vaccines that have a very long duration of protection. So we are doing good for immunization campaigns in small children, but we are left with adolescents and adults that possibly can have the disease and transmit the disease again to small children, for example. So one way to use this information and to achieve a better impact in immunization strategies is preparing simulation models. Simulation models are a good way to take into account all the numerical variables that may affect the circulation of disease and try to define different scenarios. And you can see very well that in this simulation, the best results may be obtained only when you have very strong actions, including a number of different target populations for pertussis. Much lower incidence rates can be obtained if you actually target adolescents, plus household contacts, plus adults, which is very difficult to achieve. But this information is very important to balance the results that may be obtained with different approaches with the economical resources to sustain immunization strategies. One other example that is very important to describe is how immunization in a target population may prevent infection in populations that do not receive actually immunization. This example is relevant to influenza, and it was discussed a lot of times because apparently in countries like Japan, where there was for a long time a strong campaign for influenza immunization in children, they observed an indirect effect also in the elderly. This has a potential implication that is very important. If we are able to prevent the infection with immunization in the age group where the infection is most frequent, influenza is most frequent in children, we limit the circulation of the disease and we can measure some effects in other target groups. In this example, Japan, for the period when children were targeted for influenza immunization, measured a decrease of influenza rates also in older people, which is sound. And the same effect was not apparent actually in the United States, where actually there was no variation in the rate of children immunized in the paper that we are describing right now. The same thing can be described for pneumococcal immunization. Even in this example, in the years when the conjugate pneumococcal vaccines were introduced, the first ones, we observed that even if the target populations for this immunization were children, small children in the first year of life, other age groups actually were experiencing a reduction in the incidence of the disease, simply because the circulation of the disease was decreased by immunization of the different age group. In this slide, you can see that not only children below 1 year of age, but also those with, in the second, in the third, and in the fourth year of life had a drop in the incidence rate associated to the effect of a large immunization rate with conjugate pneumococcal vaccines. Another effect which is very important and might be measured for bacterial diseases is actually observed for resistance to antibiotics. Again, this effect is apparent when immunization rates are high against pneumococcal diseases. Once the circulation of pneumococcal infections is decreased, actually there's a decrease in the rate of infections, and a measurable effect can be seen also in the resistance to most antibiotics. This is very important because actually achieving such an important result with a sound antibiotic strategy is much more difficult. So knowing that implementing appropriate immunization strategies will affect also antibiotic resistance is good news, and is something that should be taken into account when implementing immunizations against bacterial diseases. One way of looking at the impact of immunizations is looking at not only deaths, but also looking at the number of admissions into hospitals. Everybody is familiar with the concept that varicella, at least in developed countries, is not a very severe disease. So there has been a lot of discussion about the significance of introducing varicella immunization in developed countries. But actually, if you look, for example, at this graph, you will rapidly recognize that there's a very important measure that has a justification of the introduction of this immunization, which is a significant reduction in admissions into hospital. And actually, again, well, the discussion is that possibly a reduction in the circulation of varicella is not only measured in the target population, but also in regions that actually do not have immunization in place. And that's possibly the explanation of this Spanish work where varicella rates decreased both in regions where varicella immunization was not present and where vaccination was in place, although regions where immunization was in place actually experienced a much stronger, much higher reduction of admissions due to varicella.